An E2 elimination reaction is a regioselective reaction, which means there is preferential formation of one product, one regioisomer. So let's take this alkyl halide. So here in this case, if you take a look into this, this is our alpha carbon, and these are our beta carbons. So the beta carbons, each of these beta carbons have exactly 3 hydrogens. So it doesn't really matter whether this hydrogen is subtracted or this hydrogen is subtracted. It's going to give us only one product, right? So which is going to look like this, which is a propene molecule. But when you take this alkyl halide, there is a possibility that it can give rise to 2 different products because it has got an equal number of beta hydrogens. Let's identify the alpha carbon and the beta carbon, and from there we'll find out what are the 2 different products that we'll be getting. So this is the alpha carbon, and these are our beta carbons. And the 2 beta carbons have unequal number of hydrogens, right? So here in this case, they had equal number of hydrogens, so they gave rise to only one product. But here in this case, since they have 2 different or unequal number of hydrogens on the 2 beta carbons, it's going to give us 2 products, and out of those 2 products, one of those is going to be a major product. But which one will be formed as a major product? Okay, for that we are going to follow Zaitsev rule. Okay, so this is called as the Zaitsev rule. So according to Zaitsev rule, the most substituted alkene is the most stable alkene, and therefore that is the product that will be formed in major quantity. So let's write down the 2 products that we'll be getting. If this is the hydrogen that will be abstracted, then you will form a double bond between these 2 carbons with the removal of the halide ion. So this is one of the products that is obtained. And similarly, if this is the hydrogen that's subtracted, then you will form the double bond between these 2 carbons, eliminating this bromide ion. So these are the 2 products that is obtained, and between these 2 products, obviously this is going to be the major product, since this is highly substituted, where you can see that this you have 2 hydrogens here, but here across the double bond you have a total of 3 hydrogens. So this is a highly substituted alkene, and therefore this is going to be the major product. So highly substituted alkene is also called as the Zaitsev product. So if you want to find out what is the major product, all you're going to do is you're going to find the beta carbon which has the fewest number of hydrogens, and you're going to pull the hydrogen from that carbon and form the double bond between the adjacent carbon and that carbon to form the product. Let's do some more examples here. This is our alpha carbon. So these are our beta carbons. Right? So we have 2 different types of beta carbons here, pulling the hydrogen from here, from this carbon, or from this carbon is going to lead to exactly the same product, right? But pulling the hydrogen from here, it's going to give us a different product. So let's write down the 2 products that will be obtained. So if we pull the hydrogen from this carbon, this is the product that is formed. And if we pull the hydrogen from the other carbon, then this is the compound that is formed. Now between these 2, which one is highly substituted? Obviously it's going to be this one, because you can see that there is only 1 hydrogen, but here there are 2 hydrogens across the double bond. So this would be our major product. And we got this major product by pulling the hydrogen from the carbon which has fewest number of hydrogens. So here we have only 2 hydrogens, but on these 2 beta carbons we have 3 hydrogens. So we have to pull the hydrogen from this carbon. Okay, one more example. Let's identify the alpha and the beta carbons. So this is our alpha carbon, and this one is one type of beta carbon, and this one is the other beta carbon. So since this is the carbon which has the fewest number of hydrogens, the major product will be obtained by removing the hydrogen from here. And the other product is going to look like this. And between these two, which one is highly substituted? Obviously this one. And therefore, this should be the major product, which is a Zaitsev product. Okay, Zaitsev product, because it's highly substituted. Here is the relative reactivities of alkyl halides in an E2 elimination reaction. The tertiary alkyl halides are very fast in reacting in an E2 elimination reaction compared to the secondary alkyl halide and primary alkyl halide. The tertiary alkyl halides are very reactive in an E2 elimination reaction because it's going to lead to the most substituted alkene. The major product of an E2 elimination reaction is the most stable alkene, which you get after you apply the Zaitsev rule. Right? But we have to use the Zaitsev rule with caution because not always the Zaitsev product is going to be the major product. Here are a few exceptions to the rule. The first exception is when one of the products that you get is a conjugated product. Let's work out this example. So here is the substrate. Let's find out the alpha carbons. This is our alpha carbon, and this is one type of beta carbon, and this is another type of beta carbon. Let's write down the two different products that you get by abstracting these two different types of hydrogens. So according to Zaitsev rule, you have to pull the hydrogen from the carbon which has the fewest number of hydrogens, right? So this hydrogen needs to be abstracted. When this hydrogen is abstracted, this is the product that you will be getting. But we can also abstract this hydrogen and get the other product. So other product is going to look like this. Now between these two products, we can think that this is a major product because we pull the hydrogen from the carbon which has the fewest number of hydrogens. But technically, when you do the actual experiment, this is going to be the major product. And this one is a minor product. Now, what is the reason behind why this is going to be the major product? The reason is very simple, because the new double bond that is formed is in conjugation with the already existing double bond. So these two double bonds are conjugated, and therefore this product right here is more stable, and therefore this is the major product. Here is one more problem. Again, let's find out the alpha carbon. This is our alpha carbon. We have two beta carbons here, and you can abstract any one of these hydrogens, and this can lead to the products. Now between these two, which one is the major product? Okay. Obviously, you can see that this product is the major product because these two double bonds are conjugated, right? Whereas here, there is no relationship between this double bond and this double bond, right? So this is our major product, and this should be our minor product. And since the conjugated product is more stable, you obtain that as the major product. Let's go on to exception 2. The second exception is that when you have a sterically hindered alkyl halide and a base. Now let's take a look into this reaction. Here you have a tertiary alkyl halide which is sterically hindered, and you also have a bulky base. If you go and find the beta carbon, this is our alpha carbon, and we have two different types of beta carbons here. This is one type of beta carbon, and this one is another type of beta carbon, while these two beta carbons are exactly the same. So abstracting any one of these hydrogens should give you exactly the same product. Okay, so since you have a very bulky base here, it would be hard for it to go and abstract this hydrogen, right? So according to Zaitsev rule, if you want to form the major product, you have to abstract the hydrogen from the carbon which has the fewest number of hydrogens. So, but it would be hard for this base to go and abstract this hydrogen. Hence, it will go and abstract the hydrogens which is easily accessible by the base. In which case, you will be getting, this is your major product, and this one as the minor product. So this is the major product, although this is not the Zaitsev product, this is the major product because the base that you've started is sterically hindered, and also the alkyl halide is also sterically hindered. While this is the least substituted alkene, it is still the major product because of steric hindrance. If the alkyl halide is not sterically hindered and the base is only moderately hindered, then the most stable alkene will be the major product as expected. So here is a situation where you have a secondary alkyl halide which doesn't have lots of steric hindrance, in which case the Zaitsev product is still going to be the major product, where you can see that this is your alpha carbon and these are your two beta carbons, and abstracting these hydrogens will give us the products. So between these two, we can definitely tell this is a Zaitsev product since it's highly substituted. And here in this case, since there is not a lot of steric hindrance, the Zaitsev product is still going to be the major product. So it takes a lot of steric hindrance in order to form the least substituted product as the major product. This table right here shows the amount of each product that is obtained from the reaction of a sterically hindered alkyl halide with different bases. As you can see from here, this is a tertiary alkyl halide and it is lots of steric hindrance. When the bases have been switched from less bulky to more bulky bases, you can see that the percentage of the less substituted product, less substituted alkene increases as the size of the bases increases. The third exception to the Zaitsev rule is that when you use fluoride ion as a leaving group, the major product of an E2 elimination reaction of alkyl chlorides, alkyl bromides, and alkyl iodides is normally the most stable alkene, which is basically our most substituted alkenes, which is also called as the Zaitsev product. But when you use alkyl fluoride, the major product is the least substituted alkene. Let's see this with an example. So this is an alkyl fluoride. Right? When you use this base, what happens here? This is your alpha carbon and these are your beta carbons. And these are the possible products wherein you can assume that this is to be a major product since it is the Zaitsev product. Here in this case, this is not true. And this is the major product that is obtained. Now, what is the reason behind it? If you want to answer this question, then you have to look into the transition state of the reaction. And what happens in an E2 elimination reaction? In an E2 elimination reaction, we want to remove this hydrogen and we also want to remove this halogen. And in place of it, we need to create a double bond between the two carbons, right? So as the base comes and abstracts this hydrogen, since the fluoride ion is not ready to leave because it's a poor leaving group, because it's the strongest base compared to the rest of the halide ions, it's going to develop a partial negative charge on this carbon, existing more like a carbanion. So this is going to look like a primary carbanion because of the bad leaving group. And here in this case, it's going to lead to the formation of a secondary carbanion. So the transition state is going to look more like the carbanion rather than looking more like an alkene. Now between these two carbanions, which one is more stable? For this, we have to look into the stability of carbanions. Here is the stability of carbocations, where you can see that the tertiary carbocations are more stable compared to the secondary, primary, and methyl. Whereas in the case of carbanions, the order is reversed, in which case you can see that the methyl anions are more stable. This is the most stable compared to the primary, secondary, and tertiary. So on the whole, if you take a look into this, since this is going to lead to the most stable carbanion, the least substituted alkene is the major product. Where for this product, it has to go through the secondary carbanion, which is comparatively less stable. This is a chart that explains how the leaving group is going to affect the product distribution. With alkyl iodide, alkyl bromides, and alkyl chlorides, you can see that the most stable product is the most substituted alkene. So between 2 hexene and 1 hexene, this is the most substituted alkene. And by default, you get Zaitsev product as the major product here. Only in the case of alkyl fluoride, you can see that the least substituted product is obtained as the major product of about 70%.